In this example, we're heating up a skillet from a temperature of 25.0 degrees Celsius to a temperature of 150.0 degrees Celsius. And the question is, how much energy does it take to make this change in temperature? Well, this is a pretty straightforward application of our equation, Q equals mc delta T. In the equation, Q is equal to heat. Well, that's what we're trying to find out. M is the mass. Well, we're given the mass. It's 5.0 kilograms. C is the specific heat. Now, we aren't given the specific heat, but we're told that the skillet is made of iron. And iron is listed in table 2.1 as having a specific heat of 0.4521 joules per gram degree Celsius. Finally, there's delta T. Delta T is defined as the final temperature minus the initial temperature. We were given both of those temperatures, so all we have to do is subtract them. So delta T is 150.0 degrees Celsius, the final temperature, minus 25.0 degrees Celsius, the initial temperature. When we subtract those, we get 125.0 degrees Celsius. Now make sure you understand the significant figures here. Since we're subtracting these two numbers, we use the rule for addition and subtraction. In that rule, we look at decimal place, and we report our answer to the same decimal place as the least precise number in the problem. Both of these numbers go out to the tenths place, so our answer can go out to the tenths place as well. That's why our answer is 125.0 degrees Celsius. Okay, now we're ready to use our equation, right? Well, not quite. We have a unit problem. Look at the mass. The mass is given in units of kilograms. However, the specific heat is given in units of joules per gram degree Celsius. Those units aren't consistent. We've got to make these units consistent before we continue. So, we need to convert one of the units. I'm going to convert the mass. Let's convert the mass from 5.0 kilograms into grams. To do that, we need the relationship between kilograms and grams. That's easy. That comes from the metric system. 1 kilogram is the same thing as 1,000 grams. Now we can convert. We take the number we have, 5.0 kilograms, and we make it a fraction by putting it over 1. Then we multiply by the conversion relationship. But we need to multiply so that kilograms cancels. So the 1 kilogram has to go on the bottom of the conversion relationship. So in the end, we have 5.0 kilograms over 1 times 1,000 grams over 1 kilogram. This way, kilograms cancel, and we end up with 5.0 times 10 to the 3 grams. Now we're finally ready to use our equation. We have all the units taken care of, and we have everything we need for the equation. So we put in the mass, 5.0 times 10 to the 3 grams, multiply by specific heat, 0.4521 joules per gram degree Celsius, and multiply by delta T, 125.0 degrees Celsius. When we do that, the unit of grams cancels, and the unit of degrees Celsius cancels, leaving only joules. That's good because we're solving for heat. When we multiply the numbers together, we get 280,000 joules. Now please understand why I rounded the answer to 280,000 joules. In the equation, we're multiplying three numbers. When we multiply, we count significant figures, and we report our answer with the same number of significant figures as the number with the fewest in the problem. Well, if we look at the numbers here, we have 5.0 times 10 to the 3. That has two significant figures. 0.4521 has four significant figures, and 125.0 also has four significant figures. The fewest number of significant figures in the problem is 2, so our answer can have only two significant figures. And that's why the final answer is 280,000 joules.